Good afternoon to this. My name is Rafał Stanecki. I'm policy officer at the European Commission and DG Move. So I will have pleasure to present 4 excellent projects on transport infrastructure resilience, which cover numerous areas of risk assessment, preparation, response, recovery phases, infrastructure monitoring, maintenance, simulation modeling, and safety, of course. I would start maybe with the policy aspect of the whole this effort. Transport infrastructure has a very important role in, and this is reflected in European policy framework. Also, with the time, adaptation, mitigation policies of the climate change are getting stronger role and having a stronger impact on European policy. The overarching document is called European Green Deal. So this is about how to achieve climate neutrality by 2050. And in transport, it means 90% reduction of emissions by 2050. There are numerous policies in place in order to implement Green Deal, also those which concern transport infrastructure and large-scale infrastructures. At DG Move, we have sustainable and smart mobility strategy from December 2020. There are 82 initiatives in 10 areas with concrete measures to achieve a Green Deal in 4 years. In this strategy, it is also stated that climate change, the infrastructure must be adapted to climate change and made resilient to disasters. And this aspect is being treated in a TEN-T review, Trans-European Network, European Policy on Trans-European Network, Climate Adaptation Strategy, and Guidance on Climate Proofing. In TEN-T review, transport infrastructure resilience and maintenance gain particular attention. The proposal, which is now under negotiation with co-legislators, mentions resilience to climate change, environmental and human-made disasters, cybersecurity, and other exceptional occurrences affecting functioning of EU transport system. The concept of quality of transport infrastructure has been extended into the whole life cycle of the infrastructure, and maintenance is mentioned there too. The second part is EU strategy on adaptation to climate change, and there are 4 principal objectives. Smarter adaptation, which is about actions supporting robust data and risk assessment tools, faster adaptation because climate change is accelerating, more systemic adaptation because climate change impacts various areas of our life, and increased international action for climate resilience. Now, in order to implement all this agenda, we have research. We need a solid research innovation to support it. Already in the 2 previous framework programs, FP7, Horizon 2020, 1.3 billion has been invested in over 600 projects dealing with transport infrastructure. The current research innovation program, Horizon Europe, has a total budget of 95 billion euros for 7 years. The climate, energy, and mobility cluster has 15 billion of this amount. The 4 projects which will be presented today are closely linked with objective of decarbonization, climate resilience, and digitalization. So I would like to invite the first presenter, Mr. Solas. Please come and present the RESIST project.
Thank you very much. Hello from my side. My name is Dr. Vasilis Soulas, and I'm going to present you the RESIST project. The RESIST stands for Resilient Transport Infrastructure to Extreme Events. First of all, I want to apologize on behalf of the consortium, since I'm coming from ICCS, who is the coordinator of the project, but the team who is mainly worked there, together with the rest of the consortium, is in a remote bridge somewhere in the middle of Greece, in a mountainous area, having their first trial out of the 2 trials, and the next is going to be in less than a month. The project, some first information about the project. The project is part of the Horizon 2020 project MG 7.1 2017. It is a research and innovation project. It started on the 1st of September 2018 and has a duration of 46 months. It was initially 36, but due to COVID restrictions on traveling and accessing the site, it was extended by 10 months and is going to end by the end of June this year. It has an overall budget of 4.9 million euros, and it was coordinated by the Institute of Communication and Computer Systems in Athens, Greece. There are 17 partners that compose the consortium of the projects, as you can see, spread across many countries in Europe, and there are 2 infrastructure users, 2 road operators, one in Greece and one in Italy, where the final trials are going to take place. Now, the objectives of the projects, when handling extreme events in infrastructures, and as extreme events, we can imagine events happening due to the climate change, physical corruption, or corruption and during the use, let's say, of the infrastructure, or an accident, or a man-made event. So the main concerns are first to protect the users and ensure seamless mobility. We don't want to have accidents on those critical infrastructure, but also want to respond as soon as possible when something occurs in order, let's say, to move and reshape the traffic and use alternative ways, especially in those cases where the areas are remote and there are not many alternative pathways to the final destination. The second critical objective of the RESIST project and overall is to prevent, predict, and increase the resilience of the infrastructure. And this is taking place mainly using all those sensors that were developed in the project in order to monitor the structural situation of the infrastructure and take some measurements before something more critical occurs. And of course, the last one is to react and to provide, to minimize the impact of any potential issue that happens in the critical infrastructure, and of course, finally, to restore the service and ensure this seamless mobility and close this circle of the objectives. The main target of the RESIST project is mainly bridges, large bridges on highways, and tunnels. This is the critical infrastructure that was in the core of the project. Here you can see the architecture used in the RESIST project. On the top right, you can see the critical infrastructure, which is the bridges and the tunnels. All those infrastructure is equipped with multiple of sensors. The sensors are mainly wireless because of the difficult position where it is located, most likely under the bridge or at the ceiling of the tunnel. And some of those sensors were built and were installed by these AirPass, these drones that were used in the project. So besides using already the sensors being there, the project had as one outcome the installation of wireless sensors within this infrastructure. On the right part, at the top left part, it is, let's say, this RPAS, these remote piloted aircraft systems, let's call them drones for simplicity, where they have these onboard sensors, and in Resist we used commercial drones from the expensive part of the commercial drones, and we have enhanced them with capabilities in order to support, let's say, their functionality in those restricted environments like the bridges and the tunnels. A critical part between the hardware, which is on the top layer of the architecture and the bottom layer of the application, it is the communication layer, and this is a thing that was very important in the Resist project because of the difficulty of having seamless connectivity in those specific areas. Just imagine being in the middle of a mountainous area and you have to reach and to navigate the drone, the Airbus, under the bridge. So you need specific communication schemes and multiple different communication alternatives to guide them. As part of this communication part, there was also this Redcom communication module, which is pretty much a trailer that can be installed ad hoc close to the infrastructure that you want to inspect, and you can use it in order to navigate drones, get the pictures, get the data, and interact with the drones themselves. A critical part is also the cybersecurity part, because those data have to be transferred somewhere further away from the area of the inspection. And the large circle at the bottom, it is pretty much all the different monitoring tools, the different software, the user interfaces, and the situation awareness and decision support tools that were part of the project and part of the Resist as, let's say, a reaction on when something, when a critical infrastructure has some issues to be solved, a crack or whatever is this one. Finally, on the bottom part, you can see that part of the project was a mobile application that was used to have the interaction between the users of the critical infrastructure of the roads and, let's say, the road operator. One thing is from the users to inform for potential issues in the infrastructure, and playing the role of an alternative, let's say, sensor, and the other way around to inform the road users when something happens, let's say a lane has been closed or whatever, in order to alter the traffic and minimize the impact of this situation to the traffic. Now we're getting into the actual innovations of the project. The project was very innovative in many aspects, especially in the RPAS domain. First of all, there was this aerial robots for the inspection and mounting of sensors for bridges and tunnels, which were based on commercial drones. Then they built ultrasonic sensors suitable for the AirPass, as I mentioned before. Also computer vision systems suitable for the AirPass as well, cameras and lidars. The secure and resilient communication system in order to have this seamless connectivity with the drones when they are under the bridge or when inside the tunnel. The cross-label cybersecurity solution, as I mentioned, that has to go from the actual hardware to the end applications and finally to the mobility, to the mobile application. And of course, the mobility continuity for passengers and freight under extreme events. And all of them were combined into this, as we call it, integrated Resist platform in order to support the overall functionality. Here we're going to have in a short period of time, because time flies, what are the main innovations. We have the visual inspection innovations, which was built on commercial drones, but due to the hard environment, to the harsh environment, has to be built specifically. The propellers had to be combined. There was a camera mounted on top of this octa-core drone that were used, because if you want to have a view at a very closed angle, then it's better to have the cameras on top of the drone instead on the bottom that it's usually there. There was issues with the vibration that have to be solved. The electronics have to be covered because of the harsh environment and the dust, and many other different aspects that had to be solved before deploying the drones, the ARPA systems, to the actual infrastructure. Besides the visual inspection ARPAs, there was also a contact inspection robot, which was using a mechanical arm in order to check other issues that might occur in the infrastructure, both under the bridge and, as we saw later on, within the tunnel. For that innovation, also commercial drones were used, and plenty of modifications, as you can see here, were done in order to make them possible to be installed in the corresponding infrastructure. Here you can see some more innovations that were included in the drones used for the bridge inspections, like the propeller protection is a main one because of the environment. And as I told you, there was plenty of prototypes that were finished and are being tested now under a bridge in Greece and later on in a tunnel in Italy. There is also a contact inspection robot specifically designed for the tunnels themselves, which has totally different requirements and totally different constraints. And based on also commercial drones, they have been enhanced in order to improve its capabilities, like accuracy, like to have 2D scans, etc., etc. There are plenty of details in the site of the project for if you wish to delve into those details. Also, a part of the innovations was some stereo sensors that were customly 3D printed, designed to fit in the use cases involved in the resistance. They use different high industrial cameras and onboard computers in order to have this seamless connectivity with the module I described before. Finally, one of the main applications, one of the main innovations of the project is this resist mobile applications, which is pretty much a rerouting protocol when we have a closure, both total closure of the bridge or the tunnel, or partial, in order to provide you some alternative routes and to interact mainly with the end users. Now we are in the final part of the proposal of the project, and it's going to be validated in real conditions and infrastructure. The first one, it is a bridge called Bridge T9 in the Peristeri area. It is the bridge that you can see here in a remote mountainous area in Greece, and the trials are going to take place tomorrow and the day after. And the second pilot, a dual, let's say, pilot, it is another bridge in Italy, and the St. Petronilla tunnel, also in Italy, that the trials will take place early May. And this pretty much will conclude the work to be done in the project. Thanks a lot.
Thank you, Vasilis. We have a Q&A part at the end, but if there are any imminent questions to the presentations, we can go now. I don't see any raised hands, so I will thank you very much. I will invite the next presenter, Sofia, to present Panoptis.
So, good afternoon, everyone. You might notice in your program leaflet that my name isn't included. That was due to a last-minute communication mishap with the organizers. But it's important that we're here because we're in the final stages of the project. We're finalizing it. My name is Sofia. I'm from the University of Twente, and I'll be representing the consortium, 14 partners as a whole. And to start you off with the project. So Panoptis has a quite similar, addresses a quite similar problem as the previous speaker, as the Resist project. Transportation operators and engineers, they face greater challenges regarding the inspection, assessment, maintenance of the overall road infrastructure network. And the main factors that introduce these challenges are related to aging infrastructures, climate change, extreme weather conditions, and other natural and man-made hazards. And on top of that, there's an increasing traffic demand and sometimes deferred maintenance and repairs. So just to present Panoptis in a brief, comprehensible package, what we aim to do is address the problem of continuous monitoring of road infrastructures. Road debris was a factor in over 50,000 police reports crashes across a 3-year span. Car accidents have also introduced a major societal cost. Increasing landslide events and floods have introduced major societal and economical influences. So next to that, Panoptis also tries to address the microclimate monitoring by introducing forecasting and nowcasting of the microclimate around the road infrastructure. Here we try to include the factors such as temperature, humidity, wind and turbulence, frost, heat balance, and evaporation. And then finally, we're also looking at the more continuous degradation of road infrastructures that also have a major influence on day-to-day operations of road operators. We have mainly looked at the detection of cracks or potholes. So the scope of Panoptis is to provide the following list of topics, which is to provide a distributed and standardized system to optimize the multi-sensor fusion, to improve the prediction of structural and geotechnical safety of road infrastructures, to include weather modules for high-resolution tailored weather and precipitation forecasts, to include multi-hazard modeling that cover indirect climate change-related hazards, including geohazards. Think of landslides. The aim was also to design a holistic resilient assessment platform, a common operational picture, a decision support system, and combine it all in an enhanced visualization interface, which is the incident management system. Finally, we are validating and demonstrating this solution in 2 real case studies. One close to the site where Resist is also operating, near the Egnatia-Odos highway in Greece. And the other site is near a highway in Madrid in Spain. So the Panoptis ecosystem in a short, brief package is looks like this. These include the modules that I spoke about before. The decision support system, the climate change models, the common operational picture, the holistic resilient assessment platform, multi-hazard models, and the incident management system. All of this is to achieve early awareness, early warnings, and early damage assessment warnings, to enhance the response phase, to achieve automated and mitigation planning. And in order to increase resilience, the main aim, of course, is to achieve preparedness, to support adaptation and mitigation measures, and optimize response planning. So to give you a bit more examples of the actual problems that we were dealing with, I will first talk about the defect identification. Here the main objectives were to answer 2 basic questions. What kind of defects can we find on the road infrastructure, and where are the defects located? You can see on top examples of drone flights that we did on a simulated infrastructure area where we placed some debris on the road and attempted to detect and highlight them. And on the bottom, in the middle row, you can see damage detection from a mobile vehicle mapper obtained using a 360 video camera. And below, you can see a deep learning model that segments the corrosion of the steel structures under side bridges. So these deep learning modules as a singular methodology aren't that novel, but what we've tried to do is to address to improve on the accuracies, but also the speed. In case of the drone-based damage detections, we've included a onboard computation system to achieve real-time damage detection. And we also wanted to make sure that the information that is there is also included in the learning process of the road operators. Here are some more examples of pothole detections. And another example of what Panoptis aimed to do is to develop hazard models and tools. Risk is a combination of hazard, exposure, and vulnerability. So these three entities were included in the hazard models and tools. And specifically for our infrastructure, we included information on buildings, infrastructure, people. And in the specific pilot sites that we were dealing with, we mainly looked at the risk of earthquakes, landslides, and floods. So this is an example of the output of such a hazard model. Here, the hazards were visualized as a function of how probable it is that they occur within 50 to 100 to 500 years. And these models are pre-calculated. They are in the system. And the information can be retrieved immediately based on the real-time information that is being retrieved on the site itself. This is an example of of earthquake-based hazard modeling. Here, the intensity, the risk is plotted based on a function of peak ground acceleration values. Here again, those models were pre-calculated and they are stored in the system and can be retrieved based on real-time values that are being observed in the field. These models, this information is all coming together inside this integrated Panoptis tool, which looks like this. The main advantage of the system is that it allows road operators to precisely observe what the factors are that that influence a specific accident or event in their specific road infrastructure. So on the left, you can see how the tool looks like when you just look at it from a surface. But if you then click on a specific accident or event, you can see the more integrated information, the precise information that gives an expert a better view on what's happening. In addition, there's a research tab, a resource tab that gives the road operators a precise view on what kind of equipment and what kind of resources they have to their availability that they can use. So those resources include, for example, drones, mobile vehicles, meteo stations. And there's also a sensor section included that includes information on the different types of sensors that were installed in the site. And you can also view the specific warnings that were being produced based on the sensors that were installed in the site. And then finally, the forecasting and nowcasting conditions of the demo site are also included. They are, you can see very, the forecasting, nowcasting, they range up to an hour, 0 hour, 1 hour, but they can even span 2 or 3 days in advance. So that was me on behalf of the consortium. I would encourage you to note down the name Panoptis in your leaflet because it's not in there. If there are questions that I can answer, please let me know. And also visit the website. We are closing the project in 2 months. So more results from our demos will be up shortly. Thank you.
Thank you, Sophia. Are there any questions? At the end, okay. Thank you for this very interesting presentation, and I would like to invite the next presenter, Pedro, to present project Safeway. The floor is yours.
Okay. Thank you, Mr. Chairman. Okay, my name is Pedro Arias. I am professor at the University of Vigo. I am the coordinator of the Geotechnologies Research Group. And this group is the coordinator of this project, the project Safeway. The title of this is GIS-based Infrastructure Management System for Optimized Response to Extreme Events of Terrestrial Transport Networks. Okay, this project was including the topic MG 7.1, Resilience to Extreme Natural Man-Made Events. In our consortium was working 14 partners with more than 40 people from 8 different countries. The project has started in September of 2018 until the last February, during 24 months, and with a total budget about more than €4.5 million. The aim of the project was the design, validation, and implementation of holistic methods, strategies, tools, and technical interventions in relation with the resilience of the transport infrastructures, right? Then in terms of resilience, there are 3 main components: is the preparation, response and recovery, and mitigation. And our project was addressed to improving the resilience to extreme events in these infrastructures, in these transport infrastructures. It's important, I think, in my view, to make a short review of the resilience in relation with the transport infrastructure, right? Then in the up of the graph, there are the main 3 phases of the resilience, is the preparation, mitigation, and recovery. Any action or any measure to increase the resilience must be addressed to reduce the failure probabilities, this is the preparation, reduce the consequence from failures, this is mitigation, and reduce the time of recovery, right? Then these 3 concepts can be expressed as a robustness, redundancy, and rapidity. Okay, any measure to increase the resilience must be addressed to reduce the area of the curve in the bottom of the graph, right? And of course, Safeway has the same objective to make a suggestion, a proposal of measures to reduce this area. And then, according to this, the actions of the Safeway project was addressed for these 3 phases. And for the previous phase, we have worked with a database and maps with intensity or frequency of natural extreme events, and monitoring systems as well, mainly to remote sensing techniques, and critic areas and vulnerability maps. And in the next phase, in the occurrence phase, we have worked with alternative routes, because you must consider that our project was designed in a multimodal point of view of the transport, right? Considering different modes of transport. Then for the occurrence phase, we have worked with alternative routes when the risk or the event, the strength event occur, impact knowledge of the event in the infrastructure. We have worked as well with connection systems with emergency service and infrastructure managers. Lastly, for the last phase, recovery phase, we have worked with new construction techniques and new materials, and for instance, cell repairs capability materials. And all these develops, all these tools was integrated in a SafeWay platform. I will talk more in depth about this in the next slides. Our project was divided in different components or different work packets, with different objectives, but at the same time, all together are connected and make sense to the SafeWay platform and to our objectives to design measures to increase the resilience. In this work package, we have worked with quantitative risk assessment for natural hazards, but in this case at European level, right? We have designed, or we have worked in two different tasks. The first one was a review of global European database on weather and natural hazards, and collection of open access hazard maps integrable in a GIS environment. We have worked with a more than 30 database, and this information together combining with a road and railway networks database. These actions of this task was addressed to analyze the vulnerability of the transport infrastructures. And another task was based on projections about the future scenarios. The methodology was applied in this case to calculate the risk damage and the direct cost associated to these exposed infrastructures. We have made several deliverables. All these are available in Cordis. It's open to access, right? And the other activities, other work package was dedicated to quantitative and risk assessment for extreme events, but in this case, at asset scale, right, or asset level. In the previous ones was about European scale, but in this case to asset scale. And different tasks in this work package. The first one was a structural and functional vulnerability assessment using fragile curves and degree of loose functions of these assets. Other task was about to make a framework to evaluate the impacts of natural and human man-made events on critical structures and considering different issues like human, economic, environmental, and social political. Finally, deterioration and models for deterioration prediction, reliability analysis for maintenance prioritization based on predictive models. And all these actions was addressed, as I said before, to asset scale, but in this work package we have considered as well network level. For this, the function describing the functionality loss, for instance, reduction of traffic capacity due to a given hazard intensity. The corresponding deliverables. And right, in this work package was based on remote sensing technologies. We have made a multi-scale infrastructure monitoring being to store this information. We have worked with satellite and terrestrial remote sensing technologies and techniques for inventory and inspection of critical assets. And the data collected in this task was processed using artificial intelligence technologies or artificial intelligence techniques, and specifically machine learning algorithms for automatic data processing and key performance indicators calculation. And finally, the last task was about the BIM modeling for infrastructures using open standards like IFC in this case. The deliverables. The next work package was about the monitoring by crowdsourced data and for the other side, analyzing the evacuation service. In this case, we have worked with analyzing the availability of the real-time data and new information resources that we can use for these goals. We have analyzed the advanced driver assistance systems for innovative and road monitoring. Finally, social media has a means. We have analyzed, we have worked with social media, has a means to recruit data. Overall, analyzing the influence driver behavior. The deliverables. And the other work package was the integration of the different tools, of the different ICT Safeway solutions in the same platform, in the Safeway platform. This work package was addressed to different ICT Safeway solutions, as I said before, and specifically MS Manager to visualize the information, Reticus working with satellite images, and Resuite for analyze to integrate this alphanumeric data and analysis scenario, etc. And all these tools or these ICT solutions was integrated in the platform. All these solutions work together, okay, and connecting between them. And another important work package and connected with the last phase to recovery phase was to design action plans for long-term resilience of transport network. And in this case, our approach was considering the resilience, focus on reconsideration of emergency planning. We have worked adapting needs of linear infrastructure and new design base, for instance, based on shape memory materials and fiber optics. And last but not least, an analysis of the legal and normative framework for the new solutions. Talking about the cooperation with another Horizon 2020 actions, we have made clustering activities with the projects supported in this call in the topic MG 7.1. Resist, Foresee, and Panoptis, and these projects are the representative people are here. We are working now with another Horizon 2020 project, InSafe project is the name. We are making a close cooperation with this project, and the goal of this project is for surveying technologies, safety evaluation and risk management for bridges and tunnels. Relative to the future risk needs, and several needs arise based on the results of Safeway. I have highlighted here 6, but perhaps can be more. But the more relevant for our main point of view is are these. And the first is perhaps the paradigm shift from the corrective maintenance to predictive maintenance in relative to the transport infrastructures. Perhaps must be work more in depth about the clear definition of the resilience based on quantified performance indicators, and at the same time identify the key performance indicators. It's relevant, it's important as well, the homogenization of results achieved based on new paradigms and technologies, has a monitoring technologies and crowdsourcing data. The condition assessment based on condition ratings perhaps must be included this concept of this topic in this field of work. Based on transfer quantify measures obtained from the new monitoring technologies. We think it's very important to further exploitation of remote sensing technologies, specialized to valorization the European investments in Earth observation programs, Galileo, Copernicus, Sentinel, etc. Finally, define and promote paths to standardization of this data, specifically infrastructure monitoring, information management, new sensors, smart materials, etc. Almost there. Follow up of Safeway achievements. We are working now in a exploitation agreement of the Safeway IT platform and individual service. We are exploring as well, mainly in connection with the previous one talk about the InSafe project, for the contribution to new European standards in monitoring of structural condition, information management through open standards, etc. And relative to the plans to market, some service of the Safeway IT platform achieved to the market at the end of the project, specifically Reticus, Safeway, MS Manager, etc. New versions or versions of the results and are achieving to the market. We have working as well about the business and exploitation plans are currently under development for the other tools and service. And that's all from my side. Thank you for your attention.
Thank you, Pedro, for this interesting presentation. Are there any questions at this moment? Okay, thank you. There's a question. Please go on. Actually, it's nearly ended. We are missing the last presentation, although we have a presentation. So we have to improvise. And I think in this role, it will be me, probably. So the presenter had an impediment last minute. But I think it's a very interesting project, and I would like to give you some quick overview about this project. The project is called 4C. It is about to provide cost-effective and reliable results to improve resilience of transport infrastructure, as the ability to reduce the magnitude and duration of disruptive events. They analyze a long list of these disruptive events, you can see there, and through 6 case studies. The objectives of the project are divided into 2 groups for national transport authorities and operators, and users and freight. For the first group, national transport authorities and transport infrastructure operators, the objective was to establish a science-based preventive design, operation maintenance strategies for resilient infrastructure management, methodology to monetize resilience in investment decisions, predicting and alerting on potential risk scenarios, increasing the understanding of the effects of risk scenarios, recommending the optimal resilience and infrastructure adaptation strategies, and the last one, supporting emergency dynamic management plans to ensure citizen safety and rerouting. For user and freight, the project focus on ensuring safety of citizens against extreme events and implementation of dynamic, safe and efficient contingency plans. Then implementing safer and quicker routes by means of well-defined communication tools and identification of congestion scenarios and incidents. Sorry. Yeah. we have several activities which were carried out in the project. So to develop baseline and a target level of service and level of resilience assessment. The activities included developing guidelines to define metric KPIs and KRIs, guidelines to set target values of the level of service and resilience, to integrate the measures of the level of service and resilience in governance and management. And the guidelines have been transformed into CWA, which we explained in 4C website. As well as software has been developed called governance module to support decision making. Then hybrid integration of terrestrial and satellite sensing systems for monitoring of infrastructure in the risk areas. I maybe continue with other list of activities. Improving infrastructure resilience and road safety, reducing risk and users' risk perception. It included research on pavements, drainage management, innovative engineering of links and interconnections. So this is a material side. Then we have update and preparation of methodologies, practice and solutions. Here we have climatic databases to improve the effects of climate in infrastructures, design and management of infrastructure in seismic zones, selections and definition of optimal interventions in infrastructures. Flooding methodologies, shake map scenarios, algorithms for selection and definition of efficient and optimal actions, hybrid data fusion framework, SHM algorithms. We continue with activities which were carried out in the project. The project came up with a single toolkit for infrastructure managers. There's a small picture presenting it. Besides, the project came up with operational resilience schemes covering the whole life cycle of the infrastructures and resilience phases. I'll continue. Then we have list of actually 12 mid to long-term impact of the project. I will signal all of these 12, starting with providing resilience and service definition indicators and objectives and how they should be used from the transport infrastructure manager's point of view. First one. The second one, demonstrate how structural deformation can be detected from satellites and combined with in situ sensor data and virtual physical environments. The third one, offer ways to intelligibly processing, integrate, fusing, and interconnecting big streams of data. Fourth, impact of the project, implement an asset failure prediction capability. The fifth, in new materials, design of new permeable pavements aimed to improve networks resilience. The sixth, improve the calculations for determining flow of water and floodings. The seventh, improve the design of sustainable drainage systems. The 8 provide single smart and slope protection kit. The 9th impact covers providing performance-based designs concept for safety routes for efficient traffic management. The 10th impact covers updated design, construction, and remediation plans and operational and maintenance plans. 11th impact covers dynamic approach to the communication and contingency plans. And the last impact on psychological and behavioral dimension is about perception and decision making in a way that can capture users' attitude to transport risks and allowing for more detailed, precise contingency plans. I would stop here. I hope it was interesting, this improvised presentation. Thank you. I'm giving floor to Thierry Gauget for the last part. He is prepared.
Thank you, Rafal. So resilience is a very important topic, as you know, and if we look at the list of the whole program, if we can just imagine that if the network, if the road is broken down, everything here falls down. So the infrastructure, the hard infrastructure, and everything around it is definitely essential. And well, I'm very happy to see that a normal program for a conference normally set up about 5 minutes for questions, and we always end up with 30 seconds, allowing one question if still time. And this time, for this resilience session, we actually have almost 40 minutes. So imagine how long we have now to discuss all together. And I think this is something that, sorry?
Please lock the door.
So we don't need to lock the door. I'm sure that we will find a way to, or we will seize the opportunity to discuss more in length about this critical issue of resilience. So what I'd like to do is maybe to, let's say, arrange this discussion into a set of 3 main questions from my side, to which I will also invite the audience to complement, so that it's quite interactive between all of us. And so, well, Rafal, I will not ask you to respond on behalf of the last project which was presented, but I will certainly ask the other one to contribute. And well, I'd like first to go for the first set of questions. And you presented extremely well the achievement in each of your specific projects. And I think that what could be nice now to well, slightly give more insight to the audience is about the, let's say, the critical element of the different technologies you mentioned, so, and especially the maturity of each of them. So in all the sets of information you gave now, could you please tell us where are you in the maturity development of your system solution and the let's say, component technologies that are behind. And for that, I would probably start with you, Vasilis, as you were the first speaker, but don't worry, the other one will be also asked the same question.
No,
so,
I will be short, I'm not needing 40 minutes. Well, I think that as we saw there in the architecture, as you go from bottom to the top layers, I think are very mature. The ARPAS systems, the communication systems, the sensors, all those stuff are in high TRL. Actually, they are going to be presented now in the real world, in the real setup, so you can assume that it is the TRL 7 or 8. And I think with some extra effort on resiliency, as you said, mainly it could reach a final product soon. So I think that the communication parts, the sensor parts, the drone parts are all very mature. What I think is still needs a lot of work and effort, and I think it needs a higher, a larger, let's say, probably testing and trialing is what also Professor Arias mentioned in the last slot. So it is this risk assessment and the predictive part. So we need to go from reaction to prediction, which is quite, I think, tricky, because you don't want to react early, because you cannot close the main roads for a long time for a potential issue, but you can also don't want to act very late, because then it is even more worse. So I think in that level, this risk assessment management and all those stuff, I think at least in the Resist project, the TRL is slow, and I think more work is needed there, and probably this can be done also with the participation of then users, which can potentially act as participatory sensing, let's say, components in the whole solution.
Mm-hmm. Thank you, Vasilis. Well, what about you, Pedro?
Okay. In my view, it's a really difficult question, right? Because in the resilience, we must consider two different levels. At asset level or a big scale level, at a network level or actually European or a country level, right? Then it's difficult to prioritize one of these component or one of these elements in terms of the resilience. It's difficult to say which is more important than other, okay? Because all these elements must work together. Then, in my view, to think about the resilience and forgetting some of these components is, I think, is difficult, right? Then, to study or to know in depth in the specific, each of these specific levels are different techniques, different technologies. In my view, all are important. But perhaps the remote sensing techniques, it's an opinion, right? Perhaps some people of the audience is not agree with me, right? Yeah. But in my opinion, perhaps the remote sensing techniques is the more relevant, because if you want to work in anticipate mode, perhaps is the most important component for this, right? Mm-hmm. But it's an opinion, of course, and perhaps this opinion is not objective, because the remote sensing techniques is my field of work. Yeah, and that's all.
No, thank you, Pedro. And maybe before we go to you, Sofia, would there be some reaction to that last point from the audience? Yeah, please. I think you can speak up.
Disaster situations are a little bit different than daily life. If I'm buying a car, I have to have a TRL9 car. Or if I'm going into a social media app, a new one, it has to be TRL9. TRL4 is unacceptable. But if everything has come down, I'm in Ukraine, or if I'm in Puerto Rico after the hurricane, I'm happy to use TRL4, whatever you have. So I think this emphasis on TRL7, 9 is probably not correct when it comes to disasters. In my personal experience, I lived too. In one of the European projects, we were working on a new algorithm, decentralized algorithm for sharing seats in transportation. And all of a sudden, one day we woke up, 2,000 people were using our system. We had no idea why, because we didn't even have a monitoring system, but we had put our app in the stores just for testing. It turns out there was a bus bombing, and students in the university were trying to use us to bypass the bus system. This is in Istanbul. So all of a sudden, 2,000 people were using the system which was basically a TRL4 5. So a lot of the things we're working on in these incredible projects, I suspect they have end users who want to use them. The point is, how do we get it to them when they need it? This is really the real challenge. So you really need to be somehow tied to the industry verticals, people who do cloud systems, people who do mobile phone networks. If you can tie it to them and somehow they are in a position to make it available, they will be used, because there's nothing else available.
How would you react on that? Maybe Pedro, yeah?
Yeah, I absolutely agree with you. In our project, we have worked something about this topic and how we can make an influence in the behavior of the people, of the drivers, of the users in general of the transport infrastructures. And I agree with you, it's a very relevant and very important component, okay? Because perhaps you can have a lot of measures, but if you have not the channel to achieve to the people, it's difficult to have good results, right? Yeah, absolutely agree.
All right. Maybe Sofia, would you like just to complement this first part as well from your project side?
Yes, I'll try to give my perspective on it. The Panoptis ecosystem consists of different modules. You have the UAV part, you have the hazard modeling part, and you have the IMS system itself. And all those different modules separately, they have different TRL levels, in my opinion. We have, as a consortium, participated in this Horizon Booster program, where we try to see exactly, if you want to bring the Panoptis ecosystem to market, what do you need to do? How do you need to package all the different modules? Do you package the whole system as a whole, or do you take individual components and bring that to market? And that has been a big discussion while we were in this booster program, because the technical partners, they think at a different level than the road operators do, and in my view, there's this bridge between the information that's being produced by the technical side of the project, the technical partners, and the translation to how the information can actually be used in practical scenarios. For example, I've been working on the remote sensing part, and specifically extracting information from UAV images, but it turns out that it's not sufficient to just say there's a damage over here. You need to give a type of qualitative label to the damage, and without feedback from the road operators, that's very difficult. And just asking road operators for feedback hasn't been that straightforward either, because they also need some guidance on exactly on exactly the development of degradation, or the meaning of a certain type of degradation, and what kind of consequences a type of degradation has on their day-to-day operation. So there's sometimes this different language that everyone speaks within a project, which makes it, in my view, a bit hard to say exactly at what TRL level the Panoptis ecosystem is as a whole. But some parts of the system are very mature, such as the IMS system, the communication between the different modules and the data silos. So, yeah, not an easy answer, but.
Okay, but you tried at least.
Yes.
To give yeah. Maybe, if we continue, so maybe you wanted to react, Vasilis. Yeah.
Yeah, okay. My background is networking, so sorry for that. So I'm trying to think about examples of how your statement will be networking. I mean, we have the 5G or the 4G, which is TRL9. It works perfectly, but if there's an earthquake and there's breakdown, nothing works. So should we have installed, let's say, an ad hoc solution based on SMS, on GPRS, based on Wi-Fi, based on Bluetooth, also across the infrastructure, even if it's low TRL or low quality in case of events? I mean, it should be useful, I suppose, but where is the limit and the economic, let's say, variables where how many of those low TRL systems or low quality systems can you install in an infrastructure in order to think about, let's say, potential issues? I was working in a couple of years ago in a project that was trying to use an automatic robot that was going into a collapsed building in order to find people there. the TRL was good, was fine, but it was extremely expensive. So the firefighters that we asked for were told us how much does it cost? It costs, let's say, some hundreds of thousands. But with those hundreds of thousands, we can get pretty much low TRL or low how can I say, technology level, very mature tools in order to build, or we can buy trucks or whatever. Why do we spend that much money in case if event occurs once per 100 years, or in case of what? So, I mean, it's a nice position, but I don't think how this can be done. I mean, yes, please, yes.
Yeah.
I think these two.
Just 1 second. There is a microphone. It will be easier.
Hi again, my name is Mehmet, I'm from Logica Field Labs. What Sofia mentioned, which is basically, it is very difficult for people who are doing research to communicate with the same terms. And it is almost as if EU projects, they emphasize dissemination a lot, but they also should emphasize maybe business development as a very key concept. Especially in resilience, early stage developments have a chance to be used more so than in other projects because of the necessity, because nothing else is available. But I also agree in Vasilis' comment that not everything is going to be applicable. Out of maybe hundreds of projects and applications, maybe a dozen or two will be applicable. But how do you actually communicate and find them when everybody speaks different terminology and language? You really need, I think, a further definition in the next calls coming up to see resilience as actually a chance to create early adopter communities because of the high need in low TRL subjects. In mobility or in digitalization, etc., getting into business development is difficult unless you really achieve TRL 7, 8, 9. But in resilience, it's a requirement. Go to Ukraine now. People will talk about everything you're discussing here is a reality there now. In Istanbul, a lot of things you're discussing is a reality because Istanbul is a very accident-prone city with 20 million people, lots of migrants, refugees, floods and earthquakes and digital failures. A lot of things, tunnels, we pass through bridges and tunnels all day long, and everything you discuss, you're always scared with terrorism and everything. So low TRL solutions have a chance to get into business development ahead of other horizon calls, in my opinion, in resilience. And the way to do that is, there is now a new thing called blockchain. There is a new incentive mechanism. This is one of our projects right now. The blockchain incentive mechanism can actually reward telco companies and transport companies and cloud companies to come into early stage projects, help their deployment. Because if the TRL actually picks up later on to daily usage, they will benefit tremendously, and that blueprint is already working. The world has now an incredible amount of new projects based, I'm not talking about cryptocurrencies, by the way. I'm talking about decentralized decision-making ability using blockchain. I'm not talking about Bitcoin or anything like that. The decentralized decision-making platforms are now quite mature, and a lot of things we're discussing here can be used to incentivize big companies. And that's our project right now that we're working on at Logica. And what we find is that we are able to talk to big companies, and they're joining our calls, but we have difficulty speaking to researchers for the same reason Sofia said. When we talk to them, the language gap and the vision gap takes too much difficulty with a lot of small projects. So some sort of an interface is needed. And I know it's difficult, but I think for Europe, this is strategically important because there's a chance to create early adopter communities for emerging technologies. For example, in mesh networks, Bluetooth, Wi-Fi, if you go to Ukraine now, this is exactly what's needed right now. That's what they need, and yet no one's deploying them.
Yeah, and thank you for this. And Rafael wants to react, and this is actually, yeah, good. Please go ahead.
Thank
Rafael.
you. This was a very valid point, actually, and we have this valley of death and how to how to apply the business of projects which are developed at research innovation stage. And actually, I like this approach which you shared. We have that it can be applied at the lower TRL levels in CEF tool, Connecting Europe Facility. So 25 billion fund for developing European transport networks. Part of this money is being spent for implementing research projects, and I think this is a very good way to look how to implement resilience-related ideas into the existing transport networks. Oh. Point taken. Thank you.
Yeah, thank you very much to all this, and this also emphasize one element which was mentioned in Pedro's presentation about the redundancy of solutions. So basically, at the end, it's a network of solutions to make sure that the resilience will be at the highest level. Pedro, you wanted to add something or no? No? Okay. So this is very good. So now that we have this first set of discussion, I'd like now that we move on in a way to the next steps, and you identified now the certain level of maturity. We understood that you are not yet at TRL 9. We also understand that it's not needed necessarily to be at TRL 9 to start, but still, if we want to implement the solutions at least you have now tried to develop, there is need for the next steps to reach this full maturity. And so now I'd like that you enlighten us about these next steps, and maybe we can start first with you, Vasilis.
Well, I think the next steps are pretty much straightforward for those components that are on high mature level. I mean, they just need more trials and more stuff to become more straightforward how to adapt, let's say, a drone to become useful in such scenarios. And then I think for the rest one, Pedro had some nice points there to spend more time or more resources or more effort on this risk assessment and this participatory part, because you need data, and because those kind of events are very rare, it's very difficult, I mean, to get the useful data in order to design your system to work properly. So this is pretty much my idea, and I think I like the point that it's not always necessary to have the whole system ready to be deployed. You can have individual components like the communication part, or the drone parts, or the cybersecurity part, or the application parts that we have seen here that can be deployed as standalone components of service.
Yeah, thank you, Vasilis. Yeah, so maybe Pedro. Yeah.
Okay. In our case, the different solutions are with a different maturity level. The most important aspect for this is the origin of this tool, right? Of this IC tool, because several of them was made for private companies with a previous experience or these companies starting with a base or with a previous tool, or etc. But in another case, some of these tools was made for the university, and in this case, the maturity level is different, right? It's absolutely different. As well, because in the ICT tools based on the university results are goes more to the scientific component, new paradigms, etc. Right? Then it's not the same maturity level, and to achieve this level, perhaps the key component is the tool or the develop of the tool are close to the market, right? Okay, I don't know how we can achieve to the same level. It's really difficult because the goals is not the same, in not the same position. The companies and the big companies or SMI companies is different. But for me, it's very important. I agree with Vasilis about the different IC tools make sense alone, all right? And of course, all different tools must work together, but in any case, alone makes sense and make a space in the market, right? Okay, in our project, this is the situation. Some of these IC tools are very close to the market, are selling now, but in another case are with a TRL more far of the market.
Yeah, okay. Thank you, Pedro. And what about you, Sofia?
It's a difficult question. The system is already being used by the two end users that we have in the project, and we are getting feedback from them that is being ready to be implemented to improve the system. In that sense, the system is quite mature. What is needed for the next steps is a bit more expanded feedback from different types of stakeholders, because we have developed a system with road operators that are quite mature. They know what they're doing. They already have a technical department, a maintenance and operation department who are already doing their job without us. Before we came along, they were already doing their job. We just made their we've just attempted to make their day-to-day task a bit more efficient. But what would be most useful, I think, for improving the system is to get feedback from road operators that, for example, are located in Africa, Asia, who are dealing with poorer infrastructures, with lesser communication infrastructures, who are dealing with the impacts of climate change much more. That kind of feedback would be very useful, because what would happen if you have a flooding in an area where your corrosion sensor is located? Most likely you don't care about corrosion anymore. You care more about the event that is happening in your corridor, your road corridor. How much money is needed for that? I don't know. I don't know. And a last point I would want to add is that the UAV part, specifically in Panoptis, needs some maturement. We are dealing with regulations, especially in Europe, which prohibit us to fly closely to road infrastructures. We have to keep a certain distance and restrict our flying height, which is limiting for our research, but also to implement that information back to the Panoptis ecosystem. The rules and regulations concerning UAVs, you cannot just adapt, and it makes sense that they are there for the safety of your road users. But yeah, there's some to be gained over there. Yeah.
Mm-hmm. Thank you. I think it's been good to give further insight into these next steps, and as you know, there are in the room people representing the Commission from the different DGs and including CINEA. So it's always good for them to hear what could be some input into the next work programs, and I put an S on purpose so that it gives flexibility for that. And this is, a very important point. And maybe to finish, this last round of discussion, let's imagine that you are the owner of your technologies. You have your companies. You have, let's say, invested a lot of money, a lot of time, a lot of effort in developing it. And in the audience, you have the market. You have really a lot of opportunities to try to sell out your product. And so you are competitors now, or you could also be partnering. But so what would be the main element? How would you sell your idea? How would you convince in the room the people to buy your product? And let's start maybe again with Vasilis. It's harder, but the first one sometimes can win.
Yes, it's hard to sell now, yeah. To be honest, I have no idea, because I'm a researcher mainly, but the idea is, in order to sell something, is to find a problem that you target. The problem here is cracks, problems, issues under a bridge that it is 100 meters from the ground. So this is pretty much the selling point, to find the real problem and the difficulties of doing this with an alternative means. This is pretty much how I suppose to sell this kind of technology, that you save your time and you save resources in order to send their people with or climb down or do install sensors using other means or other technologies.
Mhm. Well,
I'm not sure that I will make many sales, but
well, I'm sure that you may convince in a way a few one.
yeah.
And so, Pedro, maybe when you hear that, how would you differentiate from this?
Okay, it's it's very difficult to make a competition with my colleagues of this table because they are very nice projects. But perhaps if I try to sell our project, perhaps the main component, or I try to highlight that our project try to affect or to design tools to increase the resilience in a multimodal point of view, okay? We have not dedicated specific our project to bridge tunnels or specific assets. We consider as well, but not perhaps done in depth like my colleagues, the projects, but our project try to study the resilience and to design measures to increase the resilience in a multimodal, right? Considering in general roads, railway, etc. And perhaps is the main difference, I don't know, or perhaps is the main advantage, okay? Because as I said before, the resilience must be considered in the two different levels, right? To be effective, right?
Mm-hmm. Yeah.
I don't know if the people are
I think I see some heads nodding. Yeah. So Pedro and Vasilis, you set the competition very high, but I'm sure Sofia will certainly try to, let's say, gain the market. So yes, Sofia, please.
Well, Panoptis is super cheap, so
You see?
so yeah, if you buy it now, then no.
You can say that.
I think the advantage of Panoptis is that it's based on rigorous science, and especially in the sites that we're working in Greece and in Spain, we have research partners who are very well knowledgeable about what's happening in that system and the kind of factors that play a role. So I think that's the main advantage. There's a lot of localized knowledge that is being utilized in the Panoptis system, and I think also we've been very adaptive to the feedback of the road operators. So once they come up to us and say, we don't understand how this is working, we don't understand what we're seeing, can you improve it, can you narrow it down, then that is being done. So I think that's the main advantage of Panoptis.
Thank you, Sofia. Bernard, please. Question here.
I have a general questions because I heard a lot about the resilience of the infrastructure against the climatic and natural actions. Nothing about the live loads, exploitation action, operation action. So what about the issue and challenge of the resilience in the future for traffic load, for operation action, because it is also something quite important.
Yeah, who would like to start answering this question? I think all of you could give a word on that.
I don't know if I understood the question correctly, but I think that the resilience will become even more important in the future because traffic is always increasing and infrastructure is always aging. So I think it will become even more important on that aspect.
Yeah, Pedro, you want to add something? Or?
No comments about this. As Vasilis said, is okay. The climate is important, but okay, it's another component. I think I insist in my main idea is all the components are work together, and all is important. Yeah, that's all.
Mm-hmm. And maybe Sofia, you want to?
It's a difficult question. I think we are considering that the traffic loads are constant, but that's not true, of course. There's less traffic during the night. So if an event happens during the night, you have less loss of life. And we aren't actively considering that, but that's something that you should consider, yes. It also, yeah, Pedro said that everything is equally important. But of course, if you want to include the loss of lives, you have to put some value on lives. That's a very difficult ethical question. What should you prioritize over the over other monitoring tasks?
Thank you, and I think Bernard, you put the finger on in a way on one item which is not really included, as you understand, which is the traffic itself. So basically, what's happening on the road due to even now CCAM and so on, all this new way of moving. So this is really good point for maybe for the next some next research. And so I see maybe a reaction from Sergio, and then another one in front. Yes, Andres.
Thank you. Hello, everybody. My name is Sergio Escriba. I'm project officer working at CINEA, European Commission. My question is to any of you who would like to react. All the projects have talked about monitoring, prediction, also infrastructure management systems. My question is about the monitoring part, and it's because we are hosted by 2.0 CCAM AirTrack, so people working really on the vehicle side. In the monitoring, you have talked about fixed sensors attached to the infrastructure and also mobile or even remote sensing. And in the next future, we will have big boxes, plenty of sensors, cameras, radars, accelerometers, automated vehicles. This is a big opportunity. I would like to have some insights from you, how you would imagine that this data can be used to fit your monitoring systems. In other words, what type of data would you like to access from this vehicle to monitor the condition of the infrastructure?
I see Pedro nodding, but this time we start with Pedro. Vasilis will have more time.
Okay. It's a very important and very relevant comment, Sergio. But we have a main problem for this issue because the car companies is a very difficult sector to access to this data. It's a clear, let's say, tendency in this moment to work with open data, okay? Because all of us know that every day new open data is possible to use, the municipalities, etc., etc. However, the car companies is very close to allow us to achieve to this data. But if in the future we can access to this, in our view, is very relevant. The cameras, it's absolutely relevant. It's very important because the cameras has a resolution to, for example, to monitoring the state of the asphalt or the assets around to the road. And we have, for us, it's a topic of interest to explore the combination between INC and GNS, etc. Right? And it's very relevant because there are a research line, or there is a research line to try to study the response of the IMU units of the car in relation with the state of the asphalt, or the state of the road, right? But the problem is to access to this data. It's difficult. In fact, it's impossible for us at this moment. And perhaps if in the future the car companies can imagine a business about this, perhaps it's possible to use, and perhaps they can open, etc. But for the moment, is the main barrier, in my view.
Yeah, Pedro, I think there is in AirTrack plenty of automotive industry representative. I see Stefan at the end. Because of time, I will not be able to expand on that, but you understand that there is a lot of potential, and it's mostly a question of how can we secure business in a way in that dimension. Before we end up, Andres, if you like to raise the last question, and then we will need to conclude the session to be resilient.
Yeah,
in a way.
sorry, because we are out of time. Andrés Monzón, Universidad Politécnica de Madrid, also on behalf of AirTrack Urban Mobility Working Group. Now, the thing is, all the three projects, you have, as always, some case studies to develop the technologies and the application and so on. But it's impossible to foresee, but in these 3-4 years, some events happen, like big rains, big flooding, landslides. Did you have the opportunity to check with the information that you could get from those events if the products you have developed could be adapted to act or to react in these cases? So the thing is, the European Commission perhaps could have some money to enlarge ongoing project when these things happen, but normally it's not. No? But do you have any information from, for example, big snow events or things like that that could be applied to the project's results?
Sofia, you want to, and you will be the one answering for everyone, please. Yeah,
Well, in short, in Panoptis, we haven't been able to really witness a large event, unfortunately. And this is something that it's not good to wish for bad things to happen, but I was sort of hoping for a larger event that we could monitor. But no, unfortunately not, to keep it short. I don't know if my colleagues have any experiences with large events?
Large events like catastrophic events, thankfully, didn't have in Resist as well. But smaller earthquakes or degradation because of the ice or the snow or the rain or the stuff, I mean, it's already observable and can be also found in the evaluation part of the thing. But yeah, but this is things that happen very rarely, and we don't want them to happen. But minor, changes and minor issues have already been monitored.
In our case, it was the same. We have worked with several pilots, but no serious events, strange events in this period. We have worked with data collection from the many years ago, but in fact we make a prediction of scenarios, but not is a real. It's not a real case.
Yeah. Thank you very much. So, we need to conclude the session, and well, you've seen that researchers are able, in a way, to be business people and trying to explain in a very concrete manner what are they doing, what are the critical elements, and what are the next steps in some straightforward and clear words. And I think, against what we normally hear, very complex and sometimes a bit fuzzy, I would like to thank very much the three speakers, Sofia, Pedro, and Vasilis, for their excellent presentation. This is, of course, well managed by Rafael, who managed the time, and I'm sorry that you saw, despite the lengths that we had, we finished after. But we are resilient because we will have a shorter break. So thank you very much, and enjoy the rest of the conference. Oui, je fais un petit vidéo. C'est dans la grande salle. Ok, ça va. Je dois aussi voir Stéphane, en fait, il m'a proposé de le voir maintenant, mais qu'est-ce qui est mieux? Est-ce que je vais dire, vous allez faire la vidéo maintenant? Ok, alors je vais dans ces cas-là lui dire que je vais faire la vidéo et que je